Hi, Parvini. How are you?
Hi, Auntie. I'm good. How are you?
Good.
Auntie, I wasn't able to submit the pictures of my homework because it
Why
wasn't
not?
letting me. It wasn't letting me submit it, so I sent it to you on WhatsApp.
What did it say, ma? If you send it in WhatsApp, it's difficult for me. What did it say?
Um, one sec.
Was it doable?
I did the homework. I wasn't able to submit it though for some reason. It says server rejected.
That's because your Gmail is full. Whichever account you're submitting it from, it's full.
Oh, okay.
Is the storage full?
Yeah.
Yeah, that's the deal.
Okay.
Okay, so once you clear it out only, you'll be able to submit.
Okay.
Okay. What else, ma? Shall we go ahead? Analytical limits was okay?
Mm, yeah.
Okay.
I just have one question. We were allowed to use calculator on the homework, right? The TI 84.
Why did you have to?
I put it in for um the ones that were like 1 second. Let me check.
Just 1 second.
Okay.
Yes, tell me, ma.
I put it in for the ones that we had to like use the unit circle on like limit tan x over 2 x equal x towards pi over 2.
It's not hard, right?
No, it's not.
Stand pi by 4, right?
Yeah.
And yeah, you don't have to use calculators.
No, it's 1.
Hmm?
The answer was 1.
Yeah, tan pi by 4, right? Yeah, but those you would have memorized in pre-calc, right?
Mhm.
Isn't it?
Yeah.
I am thinking, right?
Yeah.
Yeah, I don't think there was a need for the calculator, is my thought, ma.
Mm.
Got it now.
Okay.
I need to see tan. I don't know what you're saying. Tan. Which one was it? You
It
want me
was
to go over that?
it was question number 22.
What is going on to this class actually? Uh, okay.
I
Which one?
solved the rest of them by hand. It was just like the ones where I had to plug it in, just plug it in and not do any other work. I put them in the calculator.
Okay. Which question was it? Analytical limits, right?
Yeah.
Okay, many had not done, so I asked you to do it again. Which one, ma? On page number?
Um, page number. Sorry, 1 second. Page number 4, question 22.
Oops. Wrong group. Sorry. Sorry. 1 second, guys. 1 second, ma.
Mm.
I sent out a reminder. AP. Okay, AB Calc, right? I don't know why nobody has come for the class.
Oh, I don't know. I
Okay,
think a
let
lot of
me.
people are traveling because a 3 day weekend's coming up.
Okay. Okay. Oh, sorry, ma. What was the page number?
Page number 4, question 22.
You can have a good time learning everything. Uh, question number, ma?
22.
22. Okay. Oh, for that you needed to use the calculator, you're saying?
I just didn't want to do the work. I thought we could use the calculator, so I did it on the calculator.
You don't have to, right?
No, we don't. I don't have to. I didn't know if we weren't allowed to use the calculator.
Okay. Actually, if you don't have to, don't use it, is my honest thought.
Okay.
You see what I mean?
Yeah, I didn't use it for the other questions. It was just like 2 questions. One was this, and another one was just like that.
I just want to make sure, right? I will tell you.
Mm.
Yeah, so basically, what is tan pi by 4?
1.
Yeah, that was very easy. Right? You didn't have to use the calculator, right? No, right? Just
Yeah.
substitute pi by 2, right?
Yeah.
It'll be tan pi by 4. Do you understand, Parvini, there?
Yeah, I understand.
Okay. So why did you use it? I don't understand. Why did you use the calculator there?
Um, I don't know.
And one note, ma.
Huh?
I'm going to go ahead.
Hmm?
Did it record? Yeah, it is recording. Okay, go ahead. Recording setting. Is it recording? Does it say to you?
Yeah, it's recording.
Okay, good. Because I want it. Okay. Anyway, for those kids that have not come, right?
Mm.
So, okay, can we go ahead?
Yeah.
One second. What I was saying was, let me share my screen. This was the one, right? Extends to pi by 4, right? Limit. And x by 2 was asked, right? When you substitute pi by 2, right?
Yeah, it's pi by 2.
Yeah, so tan pi by 2 divide by 2, right? You don't need a calculator for this, is my thought. Tan pi by 2 divide by 2 is tan pi by 4, right?
Mm-hmm.
That's 1, right?
Yeah.
That's all. You don't need a calculator.
Yeah.
Can I move on?
Yeah.
Hi, Krish.
Hi, how are you?
Good. I think everybody's on the weekend mode, meaning long weekend mode. I don't see anybody in there. Let me quickly check. Yeah, Parvini. Who else should come actually to this class? You're here. Manav is not there. Krishiv is here. That's all? Yeah, I think so. Who else used to come? That's it, right? Let me check, guys. Should I check? Okay, just a minute. Give me a minute. I don't know. I'm checking. Limits analytically was good or bad? Krishiv, were you able to do analytical limits? Do you
Yeah, I
think
did it. Oh, I don't know if I submitted.
that's okay? You guys, as
It's
long as
good.
you do something and understand and you're able to produce it in the class, I'm least bothered. Can we go to 1 second? Where is your class AB Calc? Who should come? Arush is not in here. Oh my gosh. Krish, Parvini, Manav. Arush is not in here. That's okay. Let's move on. Okay. Okay, guys. So now I want to discuss asymptotes with you. After this, we'll go ahead and discuss continuity of functions. We'll define what a function is said to be continuous with three important conditions. We'll discuss that. First, we'll discuss asymptotes. This part is a little easier, vertical and horizontal. Maybe some revision from algebra 2 and a little bit in depth now. I don't know. You have to remember algebra 2. So let's see. Then continuity, we'll continue with continuity. And that brings up unit 1 end. Okay. Unit 2, we'll get started with average rate of change. Average rate of change. This is very interesting. Okay. From unit 2. This is the plan. Okay. What we covered graphical limits. We covered analytical limits. I have to give you a test on these two, I know. And then today we'll discuss asymptotes, continuity, and if time permits, average rate of change. Any questions for me till now? Okay, so we'll go with asymptotes. Let me pick up the notes for myself. Um, okay, so okay, let's see. You know how to find out vertical and asymptotes, vertical and horizontal asymptotes of a function. So let's say we have a function. Let me do it this way. 1 second. Okay. I'm assuming you're able to see what I'm writing out on the board. So assume we have a function f of x equal to something. Okay. Something on the numerator. Denominator, I have x minus b. What is the vertical asymptote of this function? What do you all remember? Or if you don't remember, it's my duty to go over. So please tell me. Only the two of you are there. Go ahead.
Is it B?
Yeah, b, because this becomes 0. If x equal to b, this becomes 0. The factors of the denominator are the vertical asymptotes, right? So naturally, this becomes 0. So denominator can never be equal to 0. If it is equal to 0, then that becomes the vertical asymptote. That becomes a discontinuity for the function. So it is the vertical asymptote. So there is a vertical asymptote at x equal to b. Now let's say we have the function x square plus 2x plus 8 divided by x square plus x minus 12. Do you remember factorization of quadratic functions or do you need help? Guys, tell me, guys. Krish, you're muted.
I remember.
Okay, then go ahead and do this. Find out vertical asymptotes.
Do you want me to say it?
Yeah, you can say it, ma. It's okay. If
Uh,
Bhavini doesn't get it, you can tell me that you didn't get it. I'll help you. Go ahead.
is a vertical asymptote x equals 3.
Good. What happened to the other one?
It got canceled with the
So it will
top, so
be
it
a
became a hole.
Yep. So x equal to 3 is a vertical asymptote, x equal to 4 is a whole. Did you get that, ma, or no?
Isn't it -4?
Sorry, ma.
Auntie,
Uh,
could you go to
do that? Okay. Did you factorize this?
yeah.
4 and 2, right?
Mm-hmm.
X square plus 4x minus 2a. Uh, how did you fact? How did you fact? Okay. Should have been minus, huh? 1 second. Did I give you incorrectly? Yeah, it should have been, okay, it should have been a -8. See, this should have been a -8. Okay, you were super fast, I think, Krish. Okay, so this was fact. I gave you a wrong problem. You got the right answer. Plus, so here 4x minus 2x minus 8 divided by x square minus 4x, no, plus 4x minus 3x minus 12. Did you get that, Parvini?
Yeah, I think I was
You
just
take,
confused because the 8 was a positive.
I know, it was my mistake. I'm sorry. Okay, divide by x times x plus 4 minus 3 times x plus 4. Having said that, x minus 2 times x plus 4 divide by x plus 4 times x minus 3. Now, do you see they get cancelled, right? So that is a whole. This is your vertical asymptote. Any question? Okay, you know that. Now, for the same function, f of x equal to x square plus 2x minus 8 divided by x square plus x minus 12. In this case, evaluate x tending to 3 minus limit f of x. Do you know what it is? How to do this? This is new to you. That's what I said. Mostly it will be a revision of algebra 2, but there will be subtle areas where we go in depth. Do you know how to do this? One easy way is you can just substitute, guys. Here, a direct substitution is really going to help. Limit extending to 3 minus f of x is what you need to find. There are several ways of doing the limit, okay? If I were you, 3 minus means 3 is here, 2 is here, 1 is here, 0 is here on the number line, right? Substitute 0, what happens? If you substitute 0, it is minus 8 by 12, minus 8 by minus 12, but that can be minus 2 by plus 2 by 3, right? And then if you substitute 1, what happens? 3 minus 8 is minus 5. Divide by, if I substitute 1, 1 plus 1 minus 12 is a minus 10. So that's equal to 1 by 2. Like that, if I move on, right? For 3 minus, meaning left side of 3, right? So I will just substitute, plug in 2.99 the whole square plus 2 times 2.99 minus 8 divided by 2.99 the whole square plus 2.99 minus 12. That's also fine. What do you get? You tell me. What will you get for limit extending to 3 minus? I want you to try it out and tell me, guys, please. Both. It's just substitution. You're going to substitute 2.99 for this. This one you can substitute 3.001.
Miss Priya,
Right.
Miss Priya,
Yeah, ma'am.
can we use calculator for this?
Yeah.
Okay, thank you.
Just find the limits. Limit finding is a little newer to you, but it's not hard though. No. Did you get it? What was the answer?
For the 2.99, I got 3.96.
What did you get?
I'm working on it and I'm a little confused.
Uh, was it hard, guys? Okay, let me go ahead and you substitute 2.99 the whole square. So what did you get there? Let me see, what will you get?
Um,
Uh-huh.
is it negative 56.65, Auntie?
I'm a little off, guys. I'll do it and see and tell you. I thought it was negative infinity. I'm going to check. T84calc.com. No, okay, yeah. T84calc.com. Let me do it and see. Three minus, right? Okay. 2.999 squared plus 2 times 2.99 minus 8. You get that? Okay. X squared plus x minus 12, right? This is 1 second, guys. 2 point. Yeah, this is such a small number. Did you see that? Okay, I'll show you. Wait, something we are missing for sure. Okay. Why, Krish? What are you getting?
I'm
Did
not
you substitute 2.999, 2.999, 2.999 the whole square? Did you do all of this? This one?
uh yeah, I was doing it and I got confused.
Okay. Should I share the calculator and show, or what do you want me to do? You just
Yeah, can
okay,
you
yeah. See, I think plugging into the calculator, I don't know what you guys, I feel like I'm getting a very small number in the denominator. Okay, if you get a very small number in the denominator, what happens? If you get a very small number in the denominator, what happens? Let's say 1 by, okay, before we go there, right? If you get a very small number in the denominator, what happens? Whenever you have a big number by a very, very small number, right? What would happen? Tell me. So let's say you have a very big number. Let's say you have infinite. Let's say you have 100. Divide by 0.00000001. What happens?
It gets bigger.
This gets bigger. This goes to infinity, right?
Mm,
Suppose if it is divided by a negative of the small number, this goes to
negative
negative?
infinity.
negative infinity. Yeah. So that you all know. So basically here, let me see, we were looking at the graph, right? So 2 by 3, 1 by 2. Let me plot that as well. So you have 0, okay, 0, you had 2 by 3. 2 by 3 is basically very less, 2 by 3. And then you had 1 by 2. 2 by 3 means 0.6, 0.5, and then what? 2.999. Let's see what happens. So basically, remember this function is what actually x plus 4 times x minus 2. Was that? Yeah. Divided by, what did we have? X plus 4 x minus 3. So here this got cancelled, right? So basically when you look at it, right, what type of function is this? Will we have a horizontal asymptote? Tell me, you have graphed rational functions, right? There are 100 ways of doing this. So can we graph this function? Do you know how to graph that function? Krishiv, do you know how to graph the function?
Yeah.
Uh-huh. How?
Uh, I give me a second to get my calculator.
Uh-huh.
Uh, I think y equals,
Uh-huh.
and then you just put the
Yeah, so do
equation.
you see it comes like this and then goes down. And then what happens? Comes like this, right? There is a
Mm-hmm.
vertical asymptote at x equal to 3, right, guys?
Yeah,
So when limit extending to 3 minus, what would happen? Left of 3.
it goes negative infinity.
Yeah, it goes to negative infinity. First of all, that is a very nice way of doing it. Okay. Parvini, are you able to get that?
Um, did we just put the whole thing in the calculator, or did we
Okay,
just?
let me show you guys. I can't have this. Wait, let me see. I have to take a screenshot of this. You guys have to note down the values, please. Okay. You have to tell me what the function is when I screen share. Okay. Now I'm going to stop the share. I'm going to show you. Okay. There are multiple ways of getting this. This one is easy actually. Okay. Stop share. Let me paste the screenshot. I'll go back. I'm here on. I will share this screen for you guys. Share. I'm not sure what are we missing. Let's see. On the calculator, right? Google Chrome. I don't know where is the tab. Oh, okay. 84calc.com is here. Share. This is so much better. Can you tell me? See, I tried it out here. Okay, now let's try. You tell me now what was the answer. You tell me what was the function. One of you tell me, guys. X squared
X squared plus 2x minus 8,
divided by.
and x squared plus x minus 12.
That's it. Okay. So let me do 2.49s. Let's try that. So I'm going to type out 2.123 square plus 2 times 2.999 minus 8. What did you get? 6.992. Does that make sense? And then what? I'll type out the next one, right? 2.999 square plus 2.999 minus 12. So you see what happens. Now let me do 6.992001 divided by, it will be a big number actually, divided by, let me put it like this, minus 0.006999. You're getting a big number, right? That's all. So what is going on here? Minus 999 you're getting, right? So what is that? Did you get it, guys?
Yeah.
So it is a minus infinity. Does it make sense?
Mm-hmm.
Limit x tending to 3 plus same x square plus 2x minus 8 divided by x square plus x minus 12 will be what then? It will be, the graph is like this.
Infinity.
Yeah, it'll be infinity and x equal to 3 is in here. Parvini, did you get that, Parvini? This is x equal to 3. That's the vertical asymptote.
Yeah, I got it, Auntie.
Okay. So this is 3 minus, this is 3 plus. So it comes from infinity, right? This will be infinity. I'll move on. You're going really slow. Let's see. Done. Yeah. Let's go to the notes. So this is what we were dealing with. Okay. So this was this one was plus infinity, this one was minus infinity. Here we go. We were here, right? This one was minus infinity, this one was plus infinity. Can I move on? Okay. Coming to horizontal asymptotes, right? So we discussed vertical asymptotes, you're sure. Horizontal asymptotes usually tell about what of the graph? What does it talk about for the graph? Horizontal asymptotes always tell us about the end behavior, right? Extending to minus infinity and extending to plus infinity, what happens? Does it approach a specific number or it just grows to infinity or grows to minus infinity? That's what it tells about. So we did learn three things in algebra 2 regarding horizontal asymptotes. Do you remember that? Do you remember learning about three things regarding horizontal asymptotes? Do you know?
I think so.
Tell me. We did learn something else in algebra 2 we learned.
Yeah,
M,
I remember that.
M greater than n, m less than n, m equal to n, correct? The power of the numerator. Now, power of the numerator, first one, let's say power of the numerator is less than the power of the denominator. So what happens? Let's say not as big. This is x, super duper big number. So if it is x squared, when you think about this, right, it will get cancelled, then this will become x. So now if this is going to be a big number. Let's say if it is 1,000. So 1 divided by 1,000 or a 10,000 becomes a very small number. So y equal to 0 will be the horizontal asymptote. Any questions? Here, let's say m is equal to n. Okay. Which one? Let's see. M is equal to n. So this one is one second, guys. M is equal to n. So they both are equally powerful. X square by x square. If you have it, we have always learned that we'll compare the coefficient of the leading power of x. So let's say this is also a big or small number. This is also a big or small number. Do you understand the concept behind this? Huh? So in that case, whatever the coefficient of the leading power of x, divided by the coefficient of the leading power of x. Here, y will be equal to 1. That is the horizontal asymptote. The last case is here x square by x. So this is a little different. The power in the numerator is bigger, meaning this is a really big number. This is a small number. So what happens? It will become equal to infinity. So there is no horizontal asymptote. Do you remember this, guys?
Yeah.
Okay. So basically the concept is this. 1 divided by a very big number will get you to 0. So y equal to 0 will be the horizontal asymptote. Now, very big number by a small number, no horizontal asymptote. Or big by big or small by small. Big number by big number or small by small. Here you will compare the coefficient of the leading powers of x to determine the horizontal asymptote. Any questions? Okay, this was just a revision of algebra 2, but we are going to look at weird ones as well. Okay, let's do some problems. Before I do that, right, I really want you to think about this. I'm going to draw a table for you. We talked about x values getting larger and larger and larger and larger, right? We are going to rank these in order. Okay, which grows the fastest, let's say. I have f of x equal to 1, x equal to 10, x equal to 100, x equal to 1,000. I'm going to put down x square, x cube, x power of 10, 2 power of x, e power of x. This is a good exercise for us to move on with problems. Tell me, guys, which grows the fastest? Now, if x equal to 1, what happens here? If x equal to 1, this is going to be 1, 1, 1, 2. You know what is the value of e?
Yeah.
Okay. So this would be, what is ln 1? What is ln 1? Forgot, huh?
Uh, yeah.
Ln 1 is 0. Yeah. See, that's what pre-calc really made us forget is what I feel there. I don't know. Okay. X equal to 10. This is a very good exercise. If we do, we'll be able to do the rest of the stuff easily. So x power of 10 is 10 power of 10. This will be 1024. This will be 22026. This will be a big exponential number, 1.05 times 10 power of 6. Ln x is still manageable, 2.303. That is why we have logarithms. Why do we have logarithms? We can have control over big numbers. Log functions grow very slowly. Here, this is going to be even harder. This itself is 100 power 2. This is 100 power 3. My goodness. Now
Auntie,
this one is, huh?
sorry, I'm home alone, but somebody's ringing the bell.
Go, go,
Can
go, 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 go. I know the problem. Okay, 10 power of 20, 1.3 times 10 power of 30, 2.7 times 10 power of 43, 1.6 times 10 power of 60. 4.605. Now, this cannot be counted in a calculator because your calculator can only calculate some values. It grows out of bounds. In that case, it gives you an overflow error. These are all overflow errors. Now, this being the case, this is 10 power of 6, 10 power of 9. This is 10 power of 1000 power 10. Na? So, 10 power of 1000. Oh, yeah, 10 power of 30. Do you get how it becomes 10 power of 30, Krisha?
No. Oh, wait. Yeah. Because it's,
You got it. 1000 power 10. This is
yeah.
10 power of 3 power 10 is 10 power of
Hmm.
30. You got it?
Yeah.
Good. So now I have given you all the values. Okay. I didn't make you do it in a calculator. Now tell me which grows the fastest. Let's rank. So, first of all, the easiest way to end this out is x is the base here,
Hmm.
right? But whereas the rest of the functions, x is the exponent.
Yeah.
Leave the ln. Ln is going to move slowly. So that's not even in the in the table to discuss. So which is which grows the fastest?
Is it 4 to
Faster,
the
yeah.
x?
Slowest is the least. Which one? 4 to the, yes. Because see, once x becomes the exponent, whichever base is the largest, that grows fastest. So this one,
Hmm.
then,
Then it's e to the x.
yup, 2, 3. The powers of x grow fastest. See, the powers of x grow fastest, and the base, whichever base is powers of x, all are powers of x. But here the base is 2, e, and 4. 4 grows the fastest. So this grows the fastest. Then e value is 2.7, right?
Hmm.
So that is second, and then 2, 3. Now, when x is the base, it doesn't grow that fast at all. X is the base. That power 10 and 3 and 2, it can be ordered, right? 10 power of 30, 10 power of 9, 10 power of 6. So I can say, can I say 4, 5, 6, and then the least is ln. Make sense, guys? Yeah, we are going to use a lot of this as we move up now. Can I move on? So you have to be able to decipher which grows the fastest. So the easiest way is x has to be in the power that grows the fastest. When several x's are in the powers, then you have to consider the base, whichever base is greater, that grows the fastest. Make sense? Can I move on? Okay, we don't need all this now. So let's see this one. Find this one exercise is easy. It's a revision of algebra 2 if you have forgotten. However, We are going to see the weird ones, right? That I'll do it on the board. Find the horizontal asymptote of f of x. F of x will be equal to x square plus 4, 3x minus 5. F of x, I'll give you three problems you're going to go ahead and do. This is just a revision. Go ahead and do. Then 1, 2, and 3. F of x equal to x plus 4 by 3x square minus 5. Come on, guys. This is not hard. It is just you're going to use the power m greater than n, m equal to n, n is greater than m. Can we try that?
Auntie, can you do one of them?
Absolutely, Ma, I can do. Okay. Krish, are you there, Krish? Okay.
Yeah, I don't know why my camera turned off. I just sent my answer.
Okay. Yeah. You just sent your answer. Oh, wow. Good one. So here, Parvini, the power m is greater than n, right? So no horizontal asymptote. Did you see, Ma? Leave alone the 4 and 5. They are not going to do anything at all. Just consider the powers of x. Make sense? Here, nothing is going to happen, right? You're just going to consider the powers of, see, the same x is there, right? So that's when you consider the leading powers of x. Y equal to 1 by 3 is the horizontal asymptote. Did you get it? Here you have x and x squared. So the denominator power is bigger. As a result, what happens? Big. This is big, this is small. So what happens? Small by big is, what will be the horizontal asymptote? Parvini, are you with me?
Yeah.
See, small by big number, what it will happen? What will happen to f of x?
It'll decrease.
Yeah, so small by big means 1 by, let's say, 2000, 3000, or 20,000, or big number. What would happen? Y will be equal to, the f of x is y. That will be equal to 0 will be your horizontal asymptote. Make sense?
Yeah.
You have to remember this. Small by big by small. This is big by small. No horizontal asymptote. Whereas equal means you have to consider the leading powers of x. Can I move on?
Yeah.
Okay. Now, how about this? This is what is critical. I'm going to give you this to give this to you. You're going to find out. How about this? X square plus 2 by x minus 1. How will you do this? I want to find the horizontal asymptotes of this function. Krish, your thoughts? Horizontal asymptotes means what? As x goes to plus infinity, I have to test. Minus infinity, I need to test. Go ahead. Shall I try?
Yeah.
Yeah. So let's see. Here, don't worry about the plus 2 and minus 1. Okay, it's useless. Okay, the plus 2 and minus 1 is such a small number when compared to that x square. X is tending to minus infinity and plus infinity, and 2 and 1 are not going to do anything there. Now, what is square root of x square? What is square root of x square?
X.
Yeah, square root of x square is only positive x I'm going to consider. However, the denominator is going to be x. The thing is, when x tends to, let's say, minus infinity, let's say it goes to a million, okay? There what happens? Both are positive. Let's say first it goes to plus, let's say 1 million it goes. What would happen for the first time when it goes to plus infinity? It is going to be 1 million by 1 million. So what is the answer? When
1.
extend to minus plus infinity, this is easy. But extending to minus infinity, what happens? X, the square root is going to be positive, whereas the denominator is going to be minus 1 million. This is going to be 1 million. What happens then? So minus 1. So here it is a 1, right? I'm sorry. So that being the case, here y equal to 1 is a horizontal asymptote. Y equal to minus 1 is another horizontal asymptote. Did I make sense?
Yeah, because it got square rooted, right?
Yep. But then as we move up, it's going to be a little harder as well. You're going to find, I can do it for you, but yeah, let me know. Limit x tending to infinity, 4x square plus 3x minus 2 divide by 3x minus 1. Question number 1. Question number 2. Limit x tending to infinity minus 4 e power of 1 by x. Third, limit x tending to infinity 5 e power of minus x. Do you think you can try? You're going to plug in the values. Square root means it should always be positive. But here they've clearly given positive infinity or negative infinity is already given. So can you try and tell me? You're just going to plug in values. Particularly infinity is what you're going to substitute. However, if there is square root, don't worry about the smaller values like 3x minus 2. Those are all not going to do anything when compared to 4x squared. Do you want to try Krish and Parvini?
Sure.
Yeah.
உருப்படியா பண்ணலாம்ல நான் வீட்டுல இருந்து. Go ahead, guys. Which one did you do? Which one did you not do? If you can tell me, I'll help you. You're going to do, please. Or let me know how you think I'll help.
I'm working on the first one right now.
Okay. The faster we go, the faster we'll finish.
Miss Priya,
Hmm.
since it's never mind.
Go ahead. Try Parvini. What do you want to know? Where are you stuck?
Since both of them will be equal powers, the first one.
Ah, that's right. Both of them will be equal powers. So what happens?
So it will be just 2/3.
Yeah, y equal to 2/3 is the horizontal asymptote. Okay, and then?
I'm a little confused with this one.
Can I ask you one more question, Parvini? Krish, you got this, right? You would have gotten this, I know.
Yeah.
So let's say, let me change this problem a little bit. This is minus infinity. What happens? What happens? Krish, can you tell?
For number 2.
For number 1, I changed it to minus infinity, right?
Oh.
So what happens? Again, it would be 2x divided by 3x because when you take the square root, it will always be positive, right?
Mhm.
So I write it down like this. However, limit x tending to minus infinity is there, right? So let's consider a big negative number. So this will be 2 times 1 million. This will be positive. The square root will be positive. However, the denominator, this will be 3 times minus 1 million, right? So what happens here? 1 million will get cancelled, but 2 times 3, 2 by 3 times minus 1 will be minus 2 by 3. Any questions? Any
No,
questions? Okay.
that makes sense.
Now, the next one. What happened to the next one? You are going to try. How about you guys try? It's easy, right? Substituting infinity. 1 by infinity was what? What is 1 by infinity? What is 1 by infinity?
Is it almost zero?
Yeah, almost zero, right? Because think about it. 1 by 100, 1 by 1000, 1 by 10,000. See, it goes on getting smaller and smaller and smaller. 1 by 10. 1 by 10 is zero point 0.1. 1 by 100 is zero point 0.01. 1 by 1000 is 0.001. 1 by 10,000 is 0.0001. Again, 1 by 100,000 will be 0.00001. You got it? So it goes on decreasing. Think about 1 by infinity or 1 by million. You got it? So,
Yeah.
so this will become 0. What is e power of 0? What is e power of 0? What is 1 power 0? What is 2 power 0? What is 3 power 0? What is e power 0? What is 4 power 0? What is power 0? Anything power 0 is
One.
1. So this becomes minus 4 times 1 is a minus 4. Any questions? This one? These are the weird ones that are new to you. Now, what happens here? You tell me. If you have a negative exponent, what do you do with the negative exponent? Here, let's work this out and then we'll go there. What is
Flip the
2 power 10?
fraction.
Yep.
Or
So
like
that,
put it one over.
yep.
Or
Parvini, do
flip.
you know ma? 2 power of minus 2 is 1 by 2 power of 2. Push it down to
Yeah.
remove the negative. To remove the negative exponent, you'll push it down, right? So here what would happen? Limit extending to infinity 5 times 1 by e power of x. What is e power of infinity? It grows. How much it grows? E power infinity. This will be a large number or a small number? Krish, are you here?
Yeah.
Yeah, so what happens here?
It would be a small number.
Which would be a small number? No, no, no. One thing is, are you listening or are you into something else there?
No, I'm listening.
Okay. So, what is this?
It would be a small number, right?
Which one would be a small number?
1 to the like 1 over e to the power of infinity.
Correct. This would be a very small number. This is 0,
Yeah.
right? So, 5 times it's tending to infinity. Infinity means literally it's a 0. 5 times 0 is a 0. So y equal to 0 will be your horizontal asymptote. This is evaluation of limits. So the value of this will be equal to 0. The value of this would be equal to minus 4. Make sense?
Yeah.
Okay. Parvini, are you following, ma?
Yeah.
Okay.
Wait, so it would be 5, right?
It won't be 5, right? 5 times 0.
Oh, yeah.
You got it?
Yeah.
Hmm. How about this? This one, you have to think a little bit. It's not hard. What would happen here?
Wait, what does it say at the top?
Sin x, ma.
Sine. Okay.
Evaluate the limit. What would happen? Okay, when don't worry about the numerator. Based on the denominator, you can say the answer.
Miss Priya,
Mm-hmm.
are we using the proofs theorem on this too?
No, 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 right? Because there limit extending to 0 sin x by x is 1, right?
Yeah.
Or x by sin x is 1, right?
Uh-huh.
Here it's different. They've asked a different limit, right?
Yeah.
So how do we do that? Substitute in C, guys. See, sine, it's very simple. It's nothing to think so much. Okay, sine x goes on and on and on and on. Minus infinity, it goes like this. It's always between 1 and minus 1, sine x. Cos x is always between minus 1 and 1. Okay, but if extending to minus infinity, right? The limit when when a function oscillates, limit is not defined. This is something we learned 2 weeks back. When a function oscillates, wherever it is, okay, when a function oscillates minus infinity, it still oscillates, right? It keeps on going like this. Plus infinity, it oscillates between minus 1 and 1 and 1 and 1, minus 1 minus 1 1, like that it oscillates, right? Whenever a function oscillates, then evaluation of limit at that point is does not exist only. Okay, the limit does not exist if it is an oscillating, if the function oscillates at a particular value at that time, at that uh, limit tending to that value, the function does not exist. Okay, so here don't worry about the sine x, but what happens to the x that's in the denominator? So is it big or small? Or horizontal asymptote, it's all about big and small numbers.
You're muted, Miss Priya.
I really want one of you to try, please. So what would happen to the denominator? What would happen
Mm,
to hmm?
Negative infinity
Yeah, so what would happen to the entire thing?
is zero, close to zero.
Zero. Yes, you got it. Denominator will become minus infinity, right? So big denominator, right? So it's like 1 by 1 million. It'll be a zero, right? How about this? You're going to try this one. Limit x tending to infinity minus 3 cos 1 by x. Evaluate this limit. Not hard, guys. What happens?
Is a -3.
Is a negative 3. Good
Is it?
job. Because
Yeah.
you substituted infinity here. 1 by a big number will be a 0. Then that becomes cos 0 is 1 minus 3 times 1 is minus 3. Very nice. Now the next one, limit extending to infinity sin x. Limit, this is very easy. Extending to infinity 5x cos x. I said whenever it oscillates, limit extending to infinity sin x still oscillates, right?
Mm-hmm.
Wherever it is, sin x still oscillates, right? So this does not exist. Again, cos x, what does it do at infinity? It oscillates, right? It does not exist. Any questions? It doesn't have a denominator at all, so it was easy to say. Can I move on? Whenever a function oscillates, it's not going to happen. Now, asymptote. Yeah, I'm good with asymptote. Let's see, guys. Give me a minute. Squeeze theorem we did already, right? So let's go ahead and try one of these then. See, I have some test prep questions. Okay, now you know how to do these, right? So why don't we try this? I don't know. Let's see. Do I? 1 second. Mm-hmm. Okay, let's go ahead and do this one. What I wanted to do, asymptotes, right? Okay. How about this? Just for practice sake, can you do a couple problems here? Let's try. A couple problems you do, then we'll go ahead and do. How about this limit extending to infinity cos of x power 5 by e power of x plus 4. Can you evaluate the limit? 1 second. Is you're going to evaluate the limit and tell me. We are really moving slowly. Go ahead.
Uh, I'm kind of confused about the e to the power of infinity thing.
What would
Or e to
happen?
the power.
E to the
Would it be
power.
infinity?
Yeah. So what would happen? Is that in the numerator or denominator?
Denominator.
Yeah. So what would happen?
Yeah.
It's in the denominator. So this entire thing becomes what?
Zero?
Yep.
But Miss Priya,
Yeah.
wouldn't the infinity be put on the top too? Because that's also x.
Good question. Okay, this is what we use the table to compare. Remember? X power of 1, x power of 2, x power of 5, x power of 6. How
Mm-hmm.
about 2 power of x, 4 power of x, 6 power of x? Which grows faster?
The 6 power of x to the power of x.
Exactly. Whenever the x is in the power, that is no comparison to these. That's why we put the table and saw.
Okay, that
Okay.
makes sense.
Yeah, when x is in the base, it grows very slowly when compared to x being in the exponent. And then how to compare? Suppose if you have 2 power of x, 3 power of x, 4 power of x, which grows faster? Naturally, 4 times 4 times 4 times 4 times 4 grows faster than 2 times 2 times 2 times 2. Make sense? So that's the concept here. Once you understand the concept, these all become so easy. Now, if you put infinity here, e power of infinity, when x is in the power, that's the fastest growth. This doesn't grow at all when compared to that. As a result, the denominator is infinity. So this is like a 1. It's not a big number at all. It's a small number by a very big number. This tends to 0. So cos 0 plus 4. 1 plus 4 is a 5. Make sense?
Yeah.
Okay.
Yeah.
How about this? You want one more, maybe? Okay, how about this? This is a little interesting. How about this? But not a hard one, this one. Mm, These are not hard. I don't know. This you know, right, guys? Limit extending to infinity, sine 2x. What is the answer to this? It's a weird one. Not a weird one. It's a by default you know the answer. Sine and cos are oscillating functions. Nothing is in the denominator. So what happens?
It does not exist.
Yeah, does not exist. How about this? Whereas, how about this? Limit extending to infinity. How about this? That's a teeny tiny bit tricky. Hmm?
I I think it's 2.
Go ahead, try, right? Good. What is it?
2
2. Why?
because
Because,
it
yeah.
turns to 0
Yeah,
and
don't worry about this value, okay? See always the denominator, okay? Immediately when it becomes infinity, this term cancels to 0 plus 2. 2. How about this? Limit extending to infinity. Cos, now we have all weird ones coming up. Root 2 by 2x minus pi x square divided by x square minus x cube plus x. Is it cube? I don't know, guys.
Is wait.
Yep. So the thing is, how do you simplify that? That's it. What's the answer? You don't need to compare the lower degrees at all.
Is it does that turn into 0?
Does this turn into 0? Good job. Why?
Um, because of the x to the power of 3, you can like factor out a negative on top and bottom.
Yeah. Yeah, so this is going to be minus x square by minus x cube, right? So it's going to be 1 by x. So what happens?
Cosine 0.
Yep. So that would be if x's denominator is tending to infinity, this entire thing becomes 0. So cos 0 is a 1. Make sense?
Miss Priya,
Yeah,
I'm a little lost on this one.
you're a little lost. Where are you lost?
How
See, the
does
question given was this, right?
uh-huh.
Now we have to analyze this. Don't worry about the lower powers of x. This is the only thing you need to be bothered about. This is the only thing in the numerator you'll be bothered about.
Okay.
Because they don't grow much faster than the other two. You got it?
Yeah.
Now minus pi x square by minus x cube is what? 1 by x, right?
Yeah.
So I can rewrite this as limit extending to infinity cos of 1 by x, right?
Oh, yeah, I get it.
Easy?
Yeah.
Yeah. It's not a hard one. The asymptotes are very easy, provided you understand the big by small, small by big and stuff. Okay, now I want to do some test prep. For that, don't have the answer. You guys have to tell me. Okay, how about this? This is a good test whether you are listening in class or not. Let me see. What is the answer to this? You're going to tell me the answer. Let's see. Tell me if you need help, then I'll help. Otherwise, you can do by yourself.
What is the u? Is that an x?
Yeah. See,
Okay.
A of U, right? A of U means
Oh
A.
yeah,
Yeah, you
yeah.
got it. You want
Mm-hmm.
me to make it bigger, Krish?
No, it's good.
Okay. It's one question.
Do I send it in chat?
Yes, please. It's just conceptually understanding things. It's very easy once you understand. Um, nice, Krish. Oh,
Miss Priya.
why Seema? Okay, here, which one will I drop? I'll drop U power, U in the base. That does not grow at all. U in the base and all, I don't want. Okay, so here, half power of U means does it grow or decay?
Decay.
Decay. So this is not considered. Here, 4 power of U, 3 power of U, E power of U. Oh, 1 second, wait. Krish, what did you have? D.
Is it?
Yeah,
Oh
yeah.
wait,
Yeah, you're right, I think. Uh,
no, I think C might
yeah,
be right.
C is right? Yeah.
Yeah, I didn't notice.
Yeah, even I did not notice. I thought first you were right. Okay. Shall I move on?
Yeah. Miss Priya.
Hmm.
After we're done with this, could you go over that the first problem we did with the vertical asymptote? I have the problem written down, so
Absolutely, no problem. Can I finish this?
yeah.
I just want to do more this test prep questions. Okay, 1 second. I just want to finish that and then only, at least that I need to finish. That's one small subdivision. That's what we did today. That's no good. Okay, how about this? Mm, okay, how about this? I don't know all of this. Let me see. How about this? You're going to try these. Let's try. You're going to think about it. That's what we learned today. These are just test prep based on what we learned. You take your time. Which grows faster? Only when x is in the um, power, it grows faster. But how do you find out the vertical asymptote?
Is it what's remaining at the bottom?
Yep. If you need help, shout out. I'll just do it on the board. If you shout out, I'll just do it on the board. No judging, no problem. Meaning this is the first time you're all doing it. So if you don't know, I'll do it on the board. If you want me to do, you have to let me know. Otherwise, think. This
Almost done.
2x cubed plus 3x plus 1 by 2 power of x. You don't even, yeah. See, one conceptual understanding you need to have is 2 power of x is an exponential growth function. Okay, will it ever come to 0? Exponential function will never touch 0. You know that, right? That's the biggest clue. Algebra 1 we learned, right? 2 power of x. The denominator, if it comes to 0, you have a vertical asymptote. But denominator is given as an exponential function, so it will never come to 0. So there is no vertical asymptote, no way. For the horizontal asymptote, you have to only consider whichever grows faster. I don't want all this, right? This is 2 power of x. X is in the power, remember? So what happens? You have to consider both plus infinity and minus infinity. So basically, right? The options given here are, if it goes to infinity, right, this will be a very huge number in the denominator, right? So if it is a very huge number, then the asymptote is, this does not grow faster. Here, x is not in the power. As a
Yes,
result,
Priya.
Yama,
I thought if the power was bigger on top, there'd be no horizontal asymptote.
ah, you have to see which grows faster. Okay, you have to see which grows faster. Here it is 2x cubed by 2 power of x. Which power? First of all, Parvini, you went, somebody was at your door when we discussed this. X cube grows faster, x power of 4 grows faster, or 2 power of x grows faster.
2 power of x.
Yes. No. Seema, x cube, when you think about it, right? Let's put it out, please. Okay, 10, 100,000. Three numbers I'm going to compare, okay? This is 1,000. This cube is what, ma? 10 power. Can I say this is 10 power of 2 whole cube, 10 power of 6, right?
Mm-hmm.
This one is 10 power of 3, power of 3 is 10 power of 9. Correct, ma?
Yeah.
Whereas 2 power of x is what? 2 power of 10, 2 power of 100, 2 power of 1,000. Do you see what I mean?
Yeah.
Which one grows faster? So whenever x is in the, this is an exponential function. Whenever the variable is in the exponent, that only grows faster. Got it?
Oh,
So
I
this is
see.
too big when compared to the numerator.
Yeah, I see. I thought the
Only when you have powers here and powers here. X is the base means then you need to compare the powers. You got it?
yeah, I
So
didn't
answer is
see
2. What
the
did you get?
x was the I didn't see the x was the exponent.
Okay. Krish, did you do this one?
This number 6, yeah, I did it.
What was the answer? You got it?
I put D.
D is correct. You can log off, Krish. Great. See
Okay,
you
thank you
later.
so much. See you next
Bye-bye.
week. Bye.
Bye-bye. Have a nice week. Yes, ma. Tell me.
Um,
What's your question?
can you go over number 6 and
You have to tell me the question.
this one, number
Number
6?
6, function that has both horizontal and vertical asymptote, right, man?
Uh-huh.
Good. The thing is, It is both horizontal and vertical asymptote. Here, tan x function, right?
Mm-hmm.
Like this, like this, like this, right?
Mm-hmm.
Will it ever have an asymptote, horizontal asymptote? It always has vertical asymptotes, right?
Mm-hmm.
Right?
Yeah.
Okay. So will this ever, denominator, will it ever become 0? Never, because of the plus 2, it will always be at least 2. Do you get it?
Yeah.
So it's not going to be 0. Okay. Now, what else we need to analyze? This one, no horizontal asymptote because the power is no horizontal asymptote, correct? X square by x, correct?
Yeah.
Now, here, this is e power of minus x, right? Let's see. Here, can it become 0? Anytime, can the denominator be equal to 0? Yes. So, taking square root, right?
Mm-hmm.
This will be square root of 2, correct?
Yeah.
Correct? Plus or minus square root of 2, correct?
Yeah.
Now, so it can have vertical asymptotes, correct?
Yes.
Plus or minus 2. Vertical asymptotes can be present at two places, plus root 2 and minus root 2, correct?
Correct.
How about the horizontal asymptote? Take this away, x by x square. Will it have a horizontal asymptote?
Um, of 0.
Yep. You got it?
Yeah.
So this is the only one that will have both.
Okay. And also, for the question where we had which was the fastest growing, the f of u equals to
Yeah,
200
yeah, yeah.
e to the power of u. I
Mm.
was confused on that one and 4 to the power of u, but like, why
Which
is
one? Which one? Which one's tell me 200?
e to the power of u
And then
4 to the power of u?
you
Um,
tell me. E's value is what?
2 point.
Where is the base smaller? 2 power of x grows faster or 4 power of x grows faster?
4 power of x grows faster.
Naturally, this is the answer. You got it?
Okay. Yeah.
What else?
Um, this was one of the questions we did at the beginning. So, f of x equals to x squared plus 2x minus 8 over x squared plus x minus 12.
Uh-huh.
And you said to find the limit of f of x when x is to 3 minus and x is to 3
Yeah.
plus.
Yeah.
I was still a little bit confused on that.
Okay, ma. What happens? See, if you factorize this, right? X
Uh-huh.
minus 3 is a factor, right? And x plus 4 was a factor, right?
Yeah.
This is the easiest way of doing this. This will be x plus 4 and x minus 2. Correct, ma?
Uh-huh.
Correct, ma?
Yeah.
Then think about it. What happens at 3?
There's
The
a
denominator is 0, then that's a vertical asymptote, correct?
yeah.
So what happens at 3?
It's
At 3, what happens at 3?
there's a vertical asymptote.
It is a vertical asymptote. So 3 minus vertical asymptote. So it was coming like this. If you substitute 0, 1 value, let's say I substituted 0 value, it was like a 2 by 3. I substituted 1 value, it was like a half. So it was coming down, coming down, coming down, coming down. Right at 3, it will go here. And then 3 plus, it will start from here. So this is minus infinity, this is plus infinity. Got it?
Got it. Thank you.
Okay. That's all.
Yeah, that's it.
Bye bye. See you next week.
Bye.
Have a
Thank
nice week
you.
ahead. Bye.
You too.